Imagine for a second that we're traveling along in a plane. Without wind, and depending on how good our pilot is, we would travel in a straight line. If, however, we were now to add a bit of a crosswind, that would have an effect on our direction. So if we can think of this as vector A and vector B, if we wanted to find out the resultant vector, we would need to add these together. In order to do this, we place them arrowhead to tail. Now that we've done this, we can see what the resultant vector is and our flight path, where we say A plus B. With adding vectors, it doesn't actually matter which one you add first. So if I was to add that B vector first, the wind factor, and then my flight path, you'll see that the resultant vector is still the same. A couple quick tips just before we go further. When multiplying a vector by a scalar, it will get that many times bigger. When multiplying it, for instance, by 4, it will get 4 times bigger. When multiplying vector B by a half, it will become half as large in magnitude. If you multiply a vector by a negative, its direction will change. Right, let's say for instance that we need to go from our home to meet our friends at the coffee shop. Unfortunately, going from X to Z, there's been a little bit of a bumper bashing on the way. There's an accident, we can't use that road. So what do? Jump onto Google and we say, help! So Google then has a little bit of a ponder, a little bit of a think for a moment and says, aha, I've found a solution. We can go via Y to get to Z. So we know that from X to Y, the vector is A, and from Y to Z, the vector is B. And Google's very proud of itself, as we now know the vector from X to Z is simply just A plus B. Now, if we were to change one of the directions of my vector, going for the same trip, everything would be exactly the same. The only difference would be instead of A plus B, because we're going against that traffic, instead of a plus A, it would simply be a minus A plus B. One more piece of knowledge: if a vector is parallel and the same size in magnitude, it doesn't matter where it is, you can use the letter that has been applied to it. For instance, WXYZ is a rectangle. So here we're going to have parallel equal vectors. WX is A, WZ is B. So fill those in, and then it's going to ask us find WY in terms of A and B. So we need to get from W to Y. We don't know the route directly there. There's an accident, however you want to think about it. So we're going to go via the detour. We're going to go from W to X. So that's just plus A. And then X to Y isn't given, but because it's parallel and equal, I can apply that B to it and then use it. So W to Y is A plus B. What they could also do is reverse that direction. So we need to now find Y to W in terms of A and B. Because I'm going against the grain, against the traffic in both of my two vectors, it's simply just going to be negative A minus B. Right, let's kick it up a gear. Here we have a regular hexagon. O is the midpoint of AD. Find in terms of A and C in their simplest form, BE and DB. If you want to give this one a go, pause the video now. Right, to get from B to E, we don't have a direct route. However, we know that B to C is negative A. We then can't go C to D because we haven't got what that vector is. We haven't got a letter that goes along with that vector. That road is closed, it's broken, bridge is collapsed, and in the similar thinking in terms of parallel equal vectors, that then also rules out all of these routes that we could have possibly taken. So now we need to basically work around these points. So from C, we can't go to D, so our next point is to go down to O, and that's a negative C because we're going against the grain. We can't simply just go to E. It would be easy, but we can't. So now we've got two routes that we could possibly go. We could either go down to F and then up to E, or we could go up to D and then down to E. All of those roots are known. For the sake of the video, I'm going to use this version. So we're going to go up to D, which is the same vector as OA, except negative, and then down from D to E, and once again, that's negative C. So here, similar to our algebra rules, we're just going to collect our terms. So we get BE is equal to negative 2A minus 2C. Another very quick intermission. Adding these vectors together visually sometimes helps understand this a little bit more. When we are collecting these vectors together or adding them together, what we're basically doing is taking all the x components and adding them together, and all the y components and adding them together. So let's just have a look at the x component. We can see that the resulting vector is much the same. So multiplying a by 3, or just adding a plus a, you can see we'll have the same resultant vector. To go D to B, we don't have a direct route, so let's have a look at what we have. We can't go D to C. We've already discovered that that route is blocked, and we don't have a vector for it. We do have a vector giving us a path from D to O, and then up to C, and then down to B. So our resultant D to B vector is A plus C plus A. So we've got 2A plus C as our solution. I hope it helped. Have a great day.